Imagine a city bathed in the soft glow of the morning sun. The horizon is painted with hues of gold and rose, casting a gentle warmth over a landscape that seems both familiar and utterly transformed. As the first rays of light break through the clouds, they reveal a metropolis that pulses with life and possibility. The air is crisp, carrying the faint hum of technology woven seamlessly into the fabric of daily existence. This is not just any city. This is a vision of the future, where innovation and imagination have reshaped every corner of urban life. Above the bustling streets, sleek, silver vehicles glide silently through the air, powered by unseen forces, perhaps magnetic fields, or the harnessed energy of quantum engines. These flying cars move in perfect harmony, orchestrated by artificial intelligence that ensures every journey is smooth and safe. The skyways are alive with motion, yet there is no chaos, no noise, just the quiet efficiency of advanced transportation. Below, the city's streets are lined with green spaces and walkways, where people stroll beneath the shadow of these airborne marvels, unbothered by the traffic overhead. The buildings themselves are wonders of engineering, rising high into the sky until they seem to touch the very clouds. Their glass facades shimmer with a life of their own, displaying vibrant digital art and real-time information. Some towers are covered in living greenery, vertical gardens that purify the air and provide a home for urban wildlife. Others are adorned with solar panels and wind turbines, drawing energy from the sun and wind to power the city below. At night, these skyscrapers glow with a soft, ethereal light, transforming the skyline into a tapestry of color and movement. This is New Shanghai, a beacon of human ingenuity in the 22nd century. Once a city of dreams, it has become a living testament to what humanity can achieve when creativity and technology work hand in hand. Here, the boundaries between the physical and digital worlds have all but disappeared. Holographic displays float above the streets, offering information, entertainment, and art to passers-by. Autonomous drones zip through the air, delivering goods and keeping the city running smoothly. The city is alive with activity, yet there is a sense of harmony, a balance between progress and sustainability, between ambition and care for the planet. Here, life is different. We think differently. We even see time differently. People from every corner of the world have come together, bringing their cultures, ideas, and dreams to this vibrant metropolis. They interact with technology in ways that would have seemed like science fiction just a century ago, gesturing in the air to manipulate holographic interfaces, communicating instantly across vast distances, and accessing knowledge with a mere thought. Children learn in virtual classrooms that adapt to their needs, while artists create masterpieces in digital spaces that defy the laws of physics. The city is a canvas, and its people are the artists, painting a future that is both bold and beautiful. For us, time is not a river flowing from the past to the future. It is no longer a simple, linear progression marked by ticking clocks and turning pages. Instead, time is experienced as a dynamic, ever-changing tapestry, one that can be shaped, stretched, and even glimpsed in new ways thanks to advances in quantum science. Holographic clocks display not just the hour, but the flow of data, the rhythm of the city, and the pulse of its people. Here, the past, present, and future seem to coexist, each influencing the other in subtle, profound ways. It's more like a dance, a delicate interplay of quantum connections that link every moment, every person, and every possibility. In this world, the boundaries between now and then, here and there, are blurred by the power of technology and the wonder of human imagination. The city itself becomes a living network, where ideas and emotions travel at the speed of thought, and where the future is not just awaited, but actively created, one quantum leap at a time. In the 21st century, people thought of time as a straight line. They measured it with clocks, ticking away seconds, minutes, and hours. Einstein's theory of relativity painted a more complex picture, showing that time was relative. It could speed up or slow down depending on how fast you were moving. But even then, time was still a river, flowing in one direction. The world of science was forever changed with the arrival of the quantum revolution. Before this era, our understanding of the universe was rooted in classical physics, predictable, logical, and seemingly complete. But as scientists began to probe deeper into the fabric of reality, they realized that the universe was far stranger and more mysterious than anyone had ever imagined. Driven by curiosity and the desire to unlock nature's secrets, scientists dove deep into the heart of matter. They peered into the tiniest building blocks of existence, atoms, electrons, and the particles that make up everything we see. With powerful microscopes and ingenious experiments, they uncovered a world where the rules of everyday life no longer applied, and where reality itself seemed to bend and twist in unexpected ways. In this strange new realm, they stumbled upon a phenomenon so baffling, it defied common sense: quantum entanglement. This wasn't just another scientific discovery. It was a revelation that would shake the foundations of physics. Entanglement meant that two particles could become mysteriously linked, their fates intertwined no matter how far apart they were. Picture this. Two tiny particles, perhaps created together in a lab, are then separated by unimaginable distances, across a room, across a planet, or even across the galaxy. Yet, somehow, they remain connected by an invisible thread, as if they are dancing in perfect harmony no matter how far apart they drift. Now, imagine you make a change to one of these particles. Perhaps you alter its spin or its color. Incredibly, the other particle, no matter how distant, responds instantly, as if it somehow knows what happened. This isn't just a delayed reaction or a trick of the light. The change is immediate, faster than anything we can explain with signals or messages traveling through space. Albert Einstein himself was deeply unsettled by this idea. He famously called it spooky action at a distance, because it seemed to violate everything we thought we knew about how information and time work. How could two objects, separated by light years, affect each other instantly? Entanglement forced scientists to rethink the very nature of time, space, and reality itself, opening the door to a universe far more interconnected and mysterious than we ever dreamed. The breakthrough came with the entropic time hypothesis. This theory proposed a radical idea. Time is not fundamental. It doesn't exist on its own. Instead, time emerges from something even deeper: the loss of quantum entanglement. Imagine the universe as a giant, perfectly ordered tapestry of quantum connections. As these connections break down, as information is lost, time emerges. So think of it like this. You meet someone for the first time and shake their hand. In that moment, you share a connection, a piece of information. But as time passes, you might forget their name, their face, even the feeling of their handshake. The connection just fades away. This loss of information, this forgetting, is kind of like the loss of entanglement. And well, just like that, time emerges. Let's take a break at a typical 22nd century cafe. Instead of clocks on the wall, you see shimmering orbs displaying these intricate patterns of light. These are entanglement sensors. Each sip of your quantum coffee, each word you exchange with a friend, creates a ripple in the quantum foam, a change in entanglement. We experience these changes as the flow of time. We no longer measure time in seconds, minutes, or hours. Our technology measures changes in entanglement. We've learned to manipulate these changes to slow down or speed up our experience of time. But the fundamental truth remains. Time is not a straight line, but a dance of quantum connections. Our evolving understanding of time has begun to unravel some of the universe's most profound and perplexing mysteries. For centuries, time was thought to be a constant, ticking away at the same rate everywhere in the cosmos. But as our knowledge has deepened, we've discovered that time is far more flexible and mysterious than we ever imagined. This new perspective doesn't just change how we think about the past and the future, it reshapes our understanding of the very fabric of reality itself. Take black holes, for example. These enigmatic objects are among the most extreme environments in the universe, where the familiar rules of physics seem to break down. Black holes are not just cosmic vacuum cleaners. They are laboratories for the most intense gravitational forces ever observed, and they challenge our understanding of space and time at the deepest level. When we look closely at a black hole, we see that its immense gravity warps the very fabric of space-time. Light itself bends and twists as it tries to escape, and time slows down dramatically as you approach the event horizon, the point of no return. According to Einstein's theory of general relativity, time at the edge of a black hole should come to a complete halt, frozen forever in a single moment. This idea has fascinated scientists and inspired countless stories about the nature of time and the possibility of time travel. But the entropic time hypothesis offers a new way to look at this phenomenon. Instead of seeing time as something that simply stops, we now understand that the flow of time is intimately connected to the entanglement of information and the increase of entropy. In this view, time is not a universal clock, but a process that emerges from the complex interactions of particles and energy. This means that what we perceive as the slowing or stopping of time near a black hole is actually a reflection of how information and entropy behave in these extreme conditions. Near a black hole, the entanglement that connects particles and information across the universe is stretched to its absolute limits. The fabric of reality itself is pulled so thin that the usual flow of information nearly grinds to a halt. It's as if the threads that weave together the story of the universe are being tugged apart, making it almost impossible for events to unfold in the way we're used to. This stretching of entanglement is what gives rise to the illusion that time is stopping. In reality, time doesn't truly stop at the edge of a black hole. Instead, it slows down so dramatically that from our perspective, it appears to stand still. For an outside observer, a clock falling toward a black hole would seem to tick slower and slower, never quite reaching the event horizon. But for the clock itself, time continues to move forward, just at a pace that defies our everyday experience. This remarkable phenomenon reminds us that time is not absolute. It is shaped by the universe's most powerful forces, and nowhere is this more evident than where time seems to stand still. To the people of the 21st century, I say this: open your minds to a new way of seeing time. Time is not your enemy, ticking away your precious moments. It is a reflection of your connection to the universe, a dance of quantum entanglement that makes life and indeed the universe itself possible. Embrace the quantum dance.